Hi, I'm sharing my thoughts in learning about the problem of probability and stats. This is a problem from MIT OCW of the Introduction to Probability and Stats Spring 2014 class. I will share the link of the problem and solution at the end of this video. Let's look into the problem. So we independently draw 100 data points from a normal distribution. So suppose we know the distribution is normal with variance equals to 4. We want to test the null hypothesis H0 where mu equals to 3 against the alternative hypothesis HA where mu is not equal to 3. And we want a significant level of 0.05. So we need to get the rejection region. And we also need to state the test statistic that we are using. In part B, suppose the data has 100 data points with sample mean 5. We need to calculate the p-value for this data. And we need to provide the answer if we need to reject H0. And the final part is we need to determine the power of the test using the alternative HA where mu equals to 4. Now let's look at the part A. We need to get the rejection region. We need to state our test statistic, right? So let's look at the definition first. This is the slide of 18.05 in MIT OCW. Okay, so it says that the boundary of the rejection region are called critical values. So we have the boundary are called critical values. And critical values are labeled by the probability to the right. And they are complementary to quantiles. So C.1 equals to quantiles of 0.9. So I have it here. So this is the shaded area here is referring to the quantiles. So this to the right is critical region. So they are complementary as stated here in the class note. Okay, now back to our question. We are using the test statistics Z, which is the standard normal. Okay, so let's go to the reference. So over here we are using this Z equals to x bar minus mu over sigma divided by square root of n. So there are some assumption here. So this has to be a normal distribution like what the question mentioned, and for the n is large and the sigma is known, so we were given the sigma as 2. Okay, so we just need to plug in the value later, and I make a note here to show that I can convert the equation to calculate the the other side, the X bar. Okay, and I would like to mention that this is a two-sided test. So the alpha given was 0.05, but to get the critical values of each side, we need to divide the alpha by 2. So we get 0.25 each. Now, with all the information available, we can calculate the value here. Like for standard normal, what is the value here and the value here, given that normal is the mu is 0, standard deviation is 1. So I'm going to use the RStudio to get it. Okay, so as mentioned, the RStudio command is q norm. Q stand for quantile, so we will put like 0.025 0 1. Okay, so it is minus 1.96. Okay, so I will write here minus 1.96. We can find this on the table as well, the normal table, but I'm gonna use R, which is faster. So another side, we will get Q norm 0.025, mean 0, standard deviation 1, and I will use lower tail equals to false. So when I use lower tail equals to false, I'm referring to the critical values. So it is 1.96 S. So I will write 1.96. So let me go back here to the definition. So the critical values are labeled by the probability to the right. So the critical values of 0.025, 1.96. Okay, so now we can form this answer. We will reject H0, rejection region, if Z smaller than minus 1.96. If Z is smaller than minus 1.96, or Z is larger than this 1.96 all the way to the right, then we will reject H0, the null hypothesis. Okay. So all we are doing right now is we get the standard value for the standard normal. We have now we need to switch it to back to the what the question want, the values for mu equals to 3 and sigma equals to 2. So since we already have the values, we're just going to apply this formula here to get the value on the left side and the right side. So to get the value on the left side, we'll just use the formula 3 minus 1.96. So the value to the left is 3 minus 1.96 times sigma over square root of n. Okay, so it is 2, the sigma is 2, the square root of n is actually square root of 100 is 10. So 2 divided by 10 is 0.2. So we will get 1.96 times 0.2 is 0.392. So we will get the value here as, let me write it, 2.608, and the value to the right is 3.392. Okay, so now we solve part A of this question. Okay, now we looking at part B. Part B, it says that we have 100 data points, and the sample mean for the data points is 5. So just now our H0 is, or now hypothesis is the mu equals to 3. But now out of the sample that we get, the mean of the 100 data points is 5. And the question is asking, what is the p-value? Okay, now we will get the definition of p-value first. According to the definition of the material that I got here, is p-value is the probability that we would get the sample we have or something more extreme if the null were true. Okay, so if the null says that mu equals to 3 were true, so what is the probability that we would get the sample value we have, which is 5 or more extreme? Okay, so now we will use our test statistic formula that we used in the last question to get the p-value. Okay, so we will get this. We plug in the value. We plug in the value 5 minus our mu divided by sigma over the square root of n, which is 10, and the value is 10. Okay, so what it is saying is, what is the probability that we get the value 10 or more extreme? Okay, so if we calculate this, we use R. Okay, so we will use the formula P norm. Okay, to illustrate the thoughts leading to calculate the probability of the value 10, we can first calculate the value of 1.96 first. What's the value of 1.96? Okay, so let me plug in the value for 1.96. So I put P norm 1.96 and then 0 and 1. And then I have to use the lower tail equals to false so that I get the value on the right side. I will get the upper tail probability. Okay, so as you would have guessed, this is 0.025, which is the value we got in the question part A earlier. So if the value is 1.96, the probability is 0.025. Okay, so what if the value is 10? So now I use the same equation. I just change the value to 10. Okay, before I change to 10, I will change to something more in between so that we can see the changes. Let's say I put 3. You can see that the probability is even smaller. If I put 5, okay, now it's getting really small. So 2.86 times 10 to the power of minus 7. Okay, so if we go to the value 10, which is very extreme, so it is 7.619 to 10 to the power of minus 24. Sorry, it is 7.619 times 10 to the power of minus 24. So it's a very small value, which is close to 0. So as a result, I wrote here the probability is close to 0, and therefore the probability is way smaller than the alpha of 0.05, and we will reject the H0. Okay, we have arrived at the final part of this question. Part C, we need to determine the power of the test using the alternative hypothesis where mu equals to 4. Okay, the definition of statistical power is the probability that the test correctly rejects the null when a specific alternative hypothesis is true. It is P reject H0 when H1 is true. We can look at the chart here. Okay, so this is H0. Okay, and it is the P of rejecting H0 when H1 is true. So the rejection region is over here and over here. Okay, so from part A, we know that this is 2.61 and 3.39. So anything goes to the right side of 3.39 or to the left of 2.61 is our rejection region. Okay, so given that the H1 is true, we are calculating the part with the dots. So these are the area under the curve where it is illustrated with dots. And then the shaded region here, it is the type 2 error, the beta. And power is 1 minus beta. Okay, now we look at the formulas. So power equals to P reject H0 when H1 is true. H1 is mu equals to 4. So it is actually equals to 1 minus P. We don't reject H0 when H1 is true. So we use 1 minus this part. Okay. So since we gotten the value here, 2.61 and 3.39 from part A, so we plug in the value here. So this is the formula that we need to use. 1 minus P, 2.61 to 3.39, given that mu equals to 4. This is the power. Okay. As you can see what usually we try to achieve is we want to get a bigger power or smaller beta type 2 error. Okay, so if the H0 and H1 are further apart, then the beta will be smaller. So we will have a larger power. Okay, and to get the final answer, we will standardize the value. So uh, we plug in the numbers. So 2.61 minus mu 4 divided by sigma over square root of n, which is square root of 100. That makes it 10. So by calculation, we get 1 minus p minus 6.95 to minus 3.05. So we will calculate the probability. I'm going to use R. Okay, so I will go to R. Okay, so we get the quantile of minus 3.05. So we will use P norm minus 3.05, mean 0, standard deviation 1. It is 0.00114. So, so we have the value here. And then now we get the minus 6.95 minus 6.95. Oops, I think I forgot a comma here. Okay, so it is 0 because it is really small, so system gives 0. So we will have 1 minus 0.0011 plus 0, and the final value is 0.9989. This is the answer for part C. Thank you. Here I include the reference that I use to learn about the solution of this problem. I will include the links at the video note so you guys can click on the links to check further. And you guys found any issues or any errors on the videos, you can leave a comment or let me know and I will correct them. Thank you for your time. Bye.